Hi everyone, welcome back to my channel once again. I hope all of you are doing so great. So today we are going to discuss about a topic, structure of atom. All of you are requested to take out your notebook so that you can note down the important points. So today we are specifically going to talk about the Dalton's atomic theory and J.J. Thomson's atomic model. Okay, so let's start today's session without any further delay. First of all, what is an atom? Atom is the smallest unit of any matter, right? We know that. It's the smallest unit of any matter. If you want to know about atom in more details, you can click on the I button over here and you can see that video. I have already described about the atoms in so much details like how it is making up the matter. We have already described that in another video. So a matter is made up of atom, like a pen or table or anything which we can see, even the like gases, the air, everything on the present on the earth, on the universe, it is made up of atoms. Every matter are made up of atom. Okay. Now the question is, can we break the atom? Is atom divisible or not? So now, after so many studies, after so many years of studies, now we get to know that atoms are also divisible. Okay, so there are three subatomic particles such as protons, neutrons, and electrons. Okay, so now we know this. But earlier, the first scientist, Dalton, he didn't knew this. So what he described, how he described the atom. So basically, according to the Dalton's atomic theory, every matter is made up of small tiny particles called as atoms. Atoms are not divisible and it cannot be created or destroyed in any chemical reaction. So Dalton said that atom is the smallest particle ever and we cannot divide the atom. All the atoms of a given elements are having same size, mass and the chemical properties. So for example, if I explain this point, for example, I have hydrogen atom. Now you also have hydrogen atom. Any other person also have hydrogen atom. So all of the persons, like I have hydrogen atom, your hydrogen atom, any other person sees hydrogen atom, is going to have a same size, same mass and the same chemical properties. So for a particular element, that is hydrogen, all the atoms are going to have a same size, same mass and the same chemical properties. Okay. Next point is saying, the fourth point, atom of different elements are having different size, different like mass and chemical properties. Like I have hydrogen atom, you have oxygen atom. Now both of these are going to have different size, different mass and different chemical properties. Okay. Fifth point is saying atoms combine in the ratio of a small whole number to form compounds. So whenever some atoms are combining, they always combine in the form of a whole number, like hydrogen atom and oxygen atom. When they are combining, it is going to combine like H2O. So it is a whole number. It's not going to be H half 2O or like H half O 3/4. Not like that. They always combine in a whole number ratio. Next point is saying the relative number and the kinds of atoms are constant in a given compound. So number of atoms and the kind of atoms are going to be constant for a compound. Like if I say about the water. So water will contain two hydrogen atom and one oxygen atom, and that is going to be constant for every water. Like water I have, water you have, water present in any other part of the world. So every water is going to have the same constant number of hydrogen atom and the oxygen atom. So this was elaborated by the Dalton, and this is the Dalton atomic theory. Now, can you find some irrelevant thing over here, like which is not suitable? First of all, Atom said that Dalton said that atoms are not cannot be destroyed. It is not divisible, right? But now we know that atoms are divisible. There are the subatomic particles are there, right? So this is the failure of Dalton's atomic theory. Dalton also said that all the atoms of a given element are having same size, mass and the chemical properties. But now we know that there are the isotopes are there, isobars are there. In the even the isotopes, the elements remains the same, but the mass can change, right? So what are the isotopes? That also we are going to discuss later on in next lectures. So isotopes are some elements basically which can have different mass number. Okay, so for example, hydrogen has mass 1, but there are some hydrogen which has mass 2 and hydrogen having mass 3 also. Okay, so these are the isotopes. So here the Dalton failed to explain these things. Alright, Dalton didn't knew about these things. So now this was about the Dalton's atomic theory. Next discovery was done by J.J. Thomson. J.J. Thomson discovered the electrons in the year 1897. So what was the J.J. Thomson's model of an atom and how he discovered the electrons? Let's see the. So you can see over here, this is the picture of J.J. Thomson. Okay, so J.J. Thomson did a very famous experiment that was called as cathode ray experiment or cathode ray tube. This is also called as CRT, cathode ray tube experiment. All right. Now, what is cathode ray tube experiment actually is? So here you can see this is a tube. This is called as discharge tube. So basically, in from this tube, the air, the whatever the air was present in this tube was pumped out with the help of a vacuum pump. Okay. Now he inserted some ionized gas in this discharge tube, which is having very low pressure. Suppose ionized gas of hydrogen has been inserted over here. Alright. So, and then he just connected with us in a circuit like one side is anode, another side is the cathode. Alright. Like this in the circuit, there is one positive side, one negative side. And then he provided high voltage through this circuit. Okay. So what he observed? He observed that some rays are emitted from the cathode side and these rays are moving towards the anode side. Alright, and these rays are having this green color, fluorescent color. Okay, this side it is like sparkling like a fluorescent color. So he get to know that these rays are moving in this direction, like cathode to anode direction. Now, this ray could have been a light ray as well. Light beams are also there, like laser, right? So, how he is going to identify that this is laser light or this is something else? So, he bring a magnet closer to the rays. Okay. Now, as soon as he bring a magnet closer to the rays, what happened? The rays got deflected from its position. All right. It got bent. If it was a light ray, it wouldn't have bent, right? Because you know that if you bring a magnet closer to the light, any light, it does not bend. It goes in a straight line only. Okay, but this was bending. So he thought that this might be something else. It's not just light, it's something else. So what is that? So he identified that, okay, this is moving towards the anode side, like anode side is the positive side. So these particles must be some negatively charged particles. It must be some negatively charged particles because it is attracted towards the positively charged side. Otherwise, we know that same charge are repulsive in nature and opposite charges are attractive in nature. So it must be negative, something negative. And that's how he discovered the electrons. Okay, let's watch a very interesting video which is going to explain you about this discovery and the experiment.
Cathode rays are produced in a discharge tube. A vacuum pump is used to evacuate the discharge tube. The cathode of the tube is connected to the negative terminal of the battery, and the anode of the tube is connected to the positive terminal of the battery. It was observed that, at normal pressure, the gas did not allow the current to pass through it. However, when the pressure of the tube was reduced to 0.001 mm Hg, and a high potential difference between 10 kV and 20 kV was applied, at the end of the tube, a glow was seen on the walls of glass tube. The rays emitted by the cathode travel towards anode. The attraction of rays towards anode reveals that the rays carry negative charge. Properties of cathode rays are: 1. When any object is placed in the path of the cathode rays, these rays cast shadows. This shows that cathode rays travel in straight line. 2. When a wheel was placed in the path of cathode rays, the wheel rotates. This shows that rays consist of some particle and some kinetic energy. 3. In the presence of an electric field, the rays are deflected towards the positive plate. This confirms that cathode rays consist of negatively charged particles. 4. In the presence of a magnetic field, the rays are deflected. This shows that the cathode rays are affected by the magnetic field.
Alright, students. So I hope it is clear to you. So what J.J. Thomson did, what I have explained, it is just written over here. You can pause the video and you can take the notes. So J.J. Thomson discovered the electrons. He did this using a cathode ray tube, which is a vacuum sealed tube with a cathode and anode on one end that created the beam of electrons traveling to the other end of the tube. The air inside the chamber is subjected to the high voltage. Basically, the ionized gas was present. It was not air, the ionized gas. Okay. And the electricity flowing through the air from the negative electrode to the positive electrode. So it was moving from negative to the positive side. The characteristics of the cathode rays, the electrons do not depend on the material of the electrodes and the nature of the gas which was present. Okay, because he did perform this experiment with different types of ionized gas. All right. So basically what is ionized gases? Suppose I am talking about the hydrogen ionized gas. We know that hydrogen is H plus. Okay. So if we provide so much of like energy to remove the electron, because in the hydrogen atom we know that there is one electron is present at the orbit. So what we are doing, we are just removing this electron. Okay, so it becomes like some protons plus electrons now. So this is basically the ionized gases. Okay, this is the ionized gas. So H plus electrons. This is the ionized gas. These were the electrons which are moving towards the anode side because these are negatively charged particles. So he did this experiment with different types of gases, not only the hydrogen, like other gases also. So he concluded that the this characteristics of the electrons do not depend on the material of the electrode and the nature of the gas also. Whatever the gas you take, it will be the same characteristics only. Okay. And this experiment showed that atom is not just simple indivisible particle, but it contain at least one subatomic particle, the electron, because he just discovered the electron. Okay. Now I'm going to show you another video performing this activity, performing this experiment. See this.
This is a cathode ray tube. Inside, there's nothing inside. It's actually a vacuum tube, so there's nothing but a vacuum on the inside. And it's called a cathode ray tube because this is the anode and this is the cathode. All right. When it's hooked up to an electric current, like I'm about to do here, you can see a beam moving across. You might think it's light, but when you take a magnet to light, does it do this? You can see that it's bending or deflecting away from the magnet, so we know that it's not actually light. What J.J. Thomson summarized was that he was seeing a piece of an atom flying from one end of the cathode ray tube to the other, and that the piece of the atom that he was seeing was negative based on the end of the magnet that was causing a repulsion. So the negative end of the magnet was causing a repulsion, therefore the particles must be negative.
Alright, I hope this video helps to explain you about the CRT experiment. Now let's discuss about the properties of the electrons. So J.J. Thomson find out the properties of the electron. First of all, it must be something negatively charged particles, right? Because it was moving towards the anode side. So it must be something negatively charged. Mass of the electrons is considered to be very negligible. When he calculated the mass of one electron, it was very like negligible. Okay, it's like 0.0005, like something. And the charge is like -1. Why? Because it's negatively charged. He used the symbol like E minus for the electrons. Electrons are extremely small particles, okay, and they are found outside the nucleus. So this was according to the J.J. Thomson. So according to this, he proposed a model of atom. Okay, he proposed that how the model of an atom would look like. So he proposed the very famous, it's very important students, Christmas pudding, or you can say plum pudding, or you can say the watermelon model, whatever. Like everything is correct. You can just use any one of the name. Okay, plum pudding, Christmas pudding, or watermelon model. So basically, according to this model, you can see in the watermelon, this red color part, red fleshy part, which is very sweet, tasty. We eat that. All of these red color part is like that, and seeds are embedded into this red color part in a watermelon, right? So similarly, in an atom is like a sphere only, which is a positively charged sphere. So he compared the positively charged sphere to the red fleshy part of a watermelon. Okay, and like the seeds are embedded inside the watermelon, so similarly the electrons are embedded in the sphere. Okay, and he also mentioned that the number of the positive charge and the negative charge are going to be equal in proportion. So this makes the atom to be a neutral atom. So atom is a neutral one. Alright. So this was the J.J. Thomson's atomic model. I hope this is clear to all of you students, and that is it for today's video. Alright, otherwise the video is going to be very long and I don't want to make a very long video. Okay, so the next parts are going to cover in like next videos, like the Rutherford's atomic model and the other like Neil Bohr's atomic model, what James Chadwick did, his contribution. Alright, so we are going to cover all of these in our next video. So please do keep on watching the next video also. And if you like this, hit the like button. Please share it with your friends as well. Okay, and hit the subscribe button also. All right. So take care. Have a nice day, all of you. Bye bye.